Welcome back to the 2012 Level 2 Waves walkthrough, okay? In this video, we'll be walking through question 2, refraction. One way to determine the critical angle of perspex acrylic glass is to use a semicircular perspex block through which a ray of light is passed and the angle measured. Complete the diagram below to show the path of a ray of light when used to determine the critical angle of perspex. On your diagram, mark the critical angle. The normal has been drawn for you. Okay, so in order for a critical angle to exist, okay, we are always traveling from a more dense medium to a less dense medium. So Persepex is more dense, okay, so therefore our ray will be going through Persepex and then bending and then be critical angle towards into the air, okay. So what does it mean by critical angle? So we all know that the critical angle means that what angle of incidence is required in order for the ray to bend exactly 90 degrees to the normal, okay? So what angle of incidence is required for the ray to bend perpendicular to the normal, okay? So we have our critical angle here, we'll just name it theta, and because of our size of the theta, our rays will bend so much. So in a normal situation, the rays will bend away from the normal. So it'll look something like this. But for example, as we increase this theta and theta, if we increase it, then this will bend more. Eventually, it's going to get to here, exactly 90 degrees to the normal, okay? And that's what we call our critical angle, okay? So this is all you need, okay? So you're getting the persepex, and then you're drawing 90 degrees to the normal. And this is it's a merit question, okay? You can get a merit for this question, okay? So to get a merit, you have the correct angle marked. That's just your angle theta, okay? So and your refracted ray at 90 degrees, so that's 90 degrees to the normal. And that's it, and that'll get you a merit grade. And to get an achieved grade is basically any one of those two. So either the correct angle marked or correct 90 degrees to the normal, okay? Alright, state two conditions necessary for total internal reflection to occur. So what's total internal reflection? So once again, coming back to our explanation, okay, so we're gonna have our wave, okay, so when it's traveling from more dense to less dense, it's gonna bend away from the normal. As we increase this theta, okay, this is gonna bend more, right? So eventually, okay, it's gonna get to 90 degrees, okay, that's our critical angle. But let's say I don't like my critical angle. Let's increase my critical angle to even more, okay? So therefore, this ray will bend back into the medium, okay? So instead of refracting into the air, it bends back into the persepex, okay? So that's what total internal reflection is. So what is the conditions necessary for the total internal reflection? So basically, we're gonna say that the angle of incidence is greater than the critical angle, and we must be moving from more dense medium to less dense. Okay, so why do we have to? So if we're moving from a less dense medium to a more dense medium, the rays are going to bend towards the normal, okay? So it's just going to bend towards the normal, and therefore it is impossible for the total internal reflection to occur. Okay, so that's why it has to be from a more dense medium to a less dense medium. Alright, in the above experiment, the critical angle of persepex will be found to be 42 degrees. Determine the refractive index of persepex. The refractive index of air is 1. So in this question, we're going to be using the Snoots Law, okay? So that's the N1 sine theta 1 equals to N2 sine theta 2. Okay, so that's our Snoots Law, okay? So this is the starting, so that's our angle of incidence and our refractive index, and then this part of the equation will be our second refractive index, so the refractive index of our second medium, and our angle of refraction, okay? Theta 2 is our angle of refraction. So we're traveling from persepex into air, okay? So our perspex, we're trying to find the refractive index. We don't know the refractive index for persepex, so we're still going to keep that as N1. we know that the critical angle of perspex will be found to be 42 degrees. So when the angle of incidence was 42 degrees, the ray was refracted at 90 degrees. So okay, so we say our angle of incidence was 42 degrees, and that equals to N2, a refractive index is given to us as 1, sine of 90, because it's a critical angle, so therefore it reflects refracts 90 degrees to the normal. So therefore 1 sine 90, okay, so sine 90, that equals to 1, so 1 times 1, this whole thing is just 1, okay? Therefore, n1 equals to 1 divided by sine 42. Okay, so we plug this into our calculator, so 1 divided by sine 42. That gives us the refractive index of perspex to be 1.49. Okay, so that's our refractive index for the perspex. And to get the correct perspex angle, okay, the correct perspex refractive index, that will get you a merit grade. To get an achieved grade, okay, you're working with only understanding that n1 sine 42 equals to 1. Okay, so that will get you an achieved grade here. Okay, for the last question, okay, I'm sorry, I didn't go over the last question. So in order to get the merit grade, you need both of these points. So angle of incidence must be greater than the critical critical must be greater than the critical angle. And we also say that it must be moving from a more dense medium into a less dense medium. Okay, so both of these will get you a merit grade, while any one of these, so either one, will get you an achieved. Alright, moving along. A ray of light is shown through a rectangular block of glass at an angle of 56 degrees to the surface of the glass, as shown in the diagram. The glass block is 10 centimeters long and 8 centimeters wide. Calculate the distance of the ray of light Calculate the distance the ray of light travels through the glass before emerging into the air. Okay, so basically, so what is this what is this distance here? So this distance here. So what is this distance? Okay, that's basically what the question is asking. Okay, first thing we do is we're gonna find our angle of incidence. Okay, so this 56 degrees. Okay, don't let this fool you. This is not the angle of incidence. The angle of incidence is the angle that the ray and the normal makes. Okay, so this is the normal here, and that means that the ray and the normal makes this angle here. So this is our angle of incidence here. So our angle of incidence equals to, this is 90 degrees, so 90 minus 56, and that equals to 34 degrees, okay? So our angle of incidence equals to 34 degrees, okay, not 56 degrees, okay? Okay, so, once again, we're going to be using our, once again, we're going to be using our Snoots Law to find out the angle of refraction, okay? So Snoots Law, that's once again n1 sine 1 theta 1 sine theta 1 equals to n2 sine theta 2, okay? So refractive index of air is 1, so we are traveling from air to glass, so okay, so this is our initial and this is our final, okay? So initial, our air is 1 refractive index, okay? Sine of 34, okay? That's our angle of incidence, equals to n2, that's 1.5, okay? And sine theta 2, we don't know, okay? So therefore, okay, so 1 sine 34, so that's just sine 34, 1 times anything is still just that, okay? So so sine 34 divided by 1.5 equals to sine theta 2. So therefore, we're going to say that sine, inverse of sine equals to sine 34 divided by 1.5. Plug this into your calculator. So just put this into your calculator. So inverse, we have our sine 34 divided by 1.5. And then we have our inverse sine of our answer. That gives us 21.89. Okay, so our angle of refraction, so that our theta 2 equals to 28.89. Okay, just let me double check that. No, 21. What am I doing? It's not 28. This is how you make mistakes. Okay, so 21.89 degrees. Alright, so now now the good news is that now we have our triangle here. Now we know this angle, okay? This angle, we now know it is 21.89 degrees. So we also know that because this length is equal to this length, okay? So that means that this length must be 8 centimeters. Okay, so now we can use our Pythagoras Theorem in order to find our distance, okay? So our distance is our hypotenuse, so our distance, okay? So therefore, okay, we have our angle. This is the opposite side. This is the adjacent side. This is hypotenuse. So as you can see, the adjacent side and the hypotenuse are involved. So we're going to say that use the cos rule, okay? So therefore, cos of 21.89 equals to A over H. Cos 21.89 equals to 8 divided by our hypotenuse, or just say our distance. Therefore, our distance will be achieved by doing 8 divided by cos 21.89. We'll give us our D. Okay, we plug this into our calculator. So basically, 8 divided by cos 21.89. And that should give you that the distance should give you to be 8.62 centimeters. 8.6 centimeters, yeah, 8.62, yeah, 8.6, yeah. So getting all the way to 8.62 centimeters will get you the excellence grade, okay? To get your merit grade, okay, you're looking at getting the correct refracting angle of the glass. So you're getting that the angle theta 2 is equal to 21.89 degrees will get you a merit grade. To get your achieved grade, you're looking at calculating the correct angle of incidence, okay? So like I said before, the angle of incidence is not 56 degrees, it's 90 minus 56 degrees, and that is 34 degrees. So this first step here will get you an achieved. Okay, moving on. Thank you for watching question 2 for the 2012 waves exam, okay? I'll be going over question 3 in the final question of this I'll be going over part 3 in the next video, which will cover part 3, question 3 of the exam. Thank you for watching this video. Hope you enjoyed. Bye.